Hello all. We'll discuss about atomic structure, important lines in a brief. That means in a few minutes we'll complete very important points of atomic structure which will be useful for your NEET examination or JEE mains exam. Sometimes you can think even up to advanced level also. Okay. Atomic structure, important questions. So first of all, electrons, protons and neutrons. These are subatomic particles. I am not moving into that Rutherford's model, Dalton's model and all. Along with these electrons, protons, neutrons, few more are there. Positrons, mesons, all those. 100 types generally we say. But these are important. Electrons, protons and neutrons. Whereas electron is negatively charged, proton is positively charged and neutron is electrically neutral. So when it comes to electron, -1, proton +1 charge we say, and neutron is electrically neutral, so I am not writing. Their charges are same, 1.60 to 10 to the power of minus 19 coulomb, or you say 4.8 into 10 to the power of minus 10 electrostatic units, ESU. Magnitude of the charge is same for electron and proton. The only difference is electron is negatively charged and proton is positively charged, but the values are same. Okay, now if you want for electron, you just keep it as minus, and for proton you can keep it as plus, but the value is same. Don't change the power. Okay, don't say electron is 10 power minus 19, proton is 10 power plus 19 are there. Magnitude is same, 10 power minus 19 coulombs only, but minus 1.6 like that you can keep. When it comes to mass, electron mass is negligible, very less, or is negligible you can say. Comparative mass, if you take, this is 1 by 18, 36, 37 you can say. For proton and neutron you can take this as relative mass as 1. If proton and neutron mass if you consider as 1, electron mass will be 1 by 1837 relative masses. If you want to write exact mass, it is 9.1 into 10 to the power of minus 31 kg, or you say minus 28 grams. Protons 1.672 10 to the power of minus 27 kg. Neutron is almost same, 1.674 we write almost same, minus 27 kg. Electrons, protons and neutrons, these two are relatively more mass and this is less. So the important point what you have to notice, electron is important in terms of charge, neutron is important or significant in terms of mass, but proton is important in terms of both charge as well as mass. This is one important point. And one regular question generally you will get is N, alpha, P and E. Neutron, alpha particle, proton and electron, E by M, charge to mass ratio. So this is the order. One time asked question in IIT. If you see any book, you will face this question. Neutron, alpha particle, proton and electron. This is E by M. Why like this? Very simple. Neutron, there is no charge, so this is least. Alpha particle charge is 2, mass is 4. So for alpha you can say 2 by 4. Proton charge is 1, mass is 1. Electron charge is 1, but mass is very less, that is 1 by 1837. That's why obviously it is more. N, alpha, P and E, that is N alpha, proton, electron. This is a very regular question. And electron question also they can ask you, what is E by M of electron? E by M of electron is 1.75 into 10 to the power of 11 coulomb per kilogram. This is again one important point that you can remember. Then we'll discuss few lines about isobars, isotopes and all. First we'll go with isotopes. Isotopes means Z is same. What is Z? Z is atomic number. Atomic number means protons number, or you can say electrons in the neutral atom, that is same. Z is same means this is same, and A is different. What is A? A is mass number. If A is different and Z is same, then they are called isotopes. Example, H11, H12, H13. Okay, now 1H1 we have to say like this, 1H2, 1H3. atomic number same, mass numbers different. Carbon 612, carbon 614, you can say, right? Isobars. What are isobars? Okay. A same, Z different. Example, what is the meaning of A same Z different? For example, if you take carbon 614, nitrogen 714, okay, I'll write again, carbon 614, nitrogen 714. These mass numbers are same, atomic numbers are different. So what you can say, isobars means same mass number. Mass number means neutrons plus protons number is same. Then what is different? Z. Z different means protons different. Proton different means you can say electrons different. Electrons you can say always Z, but only condition that must be a neutral atom. Only for neutral atoms Z is nothing but electrons number, but neutral. Isotones. It's interesting. Okay, isotones. In isotones, number of neutrons are same. Rest all are different. A different, Z different, P different, E different. Only same thing is number of neutrons. Let's go with one example. Carbon 613, nitrogen 714, 6 atomic number different, 13 14 mass numbers different, but 13 minus 6 is 7, 14 minus 7 is 7. The number of neutrons is same. When the number of neutrons are same, rest all are different, they are called isotones. Let's go with one more, isodiaphers. Here what happens is same n minus p or a minus 2z number, n minus p or a minus 2z, this number is called isotopic number. N minus p or a minus 2z is called isotopic number. If isotopic number is same, then they are called isodiaphers. See one example, fluorine 919, sodium 1123, 19 minus 2 into 9, a minus 2z, this is equals to 1. Here 23 minus 2 into 11, a minus 2z is equal to 1. So they are having same isotopic numbers. When the isotopic number is same, then they can be called as isodiaphers. Okay, now this you can say in terms of this also, fluorine 919, sodium 1123, 19 minus 9 is number of neutrons are 10, minus 9 is equal to 1, n minus p value. 23 minus 11 means number of neutrons are 12, minus 11 is equal to 1. So n minus p value is same in both the cases. Isosters, same number of electrons and same number of atoms. If electrons number and atoms number is same, then they can be called as isosters. Same number of electrons and same number of atoms. See, CO and N2. Two atoms are there. 1 plus 1, 2 atoms, 2 nitrogen atoms, 2 atoms, 1 carbon, 1 oxygen, 2 atoms. Carbon 6, oxygen 8, 14 electrons. 2 nitrogens, each 7, 14 electrons. Number of atoms are 2, number of electrons are same. Number of electrons, number of atoms, both are same, then they can be called as isosters. See one more example. CO2, N2O, 3 atoms, 3 atoms, 6 plus 8 and 8, 22 electrons, 2 nitrogen atoms, 14 plus oxygen 8, 22 electrons. So in both the cases that is equal to 22. So this is isosters. One more term, not exactly related here, but as isos we are discussing, we'll go with this also. Isoelectronic. If same number of electrons are present, they are called isoelectronic. The most useful example is for you lithium plus 2, beryllium plus 3. Hydrogen, helium plus lithium plus 2, beryllium plus 3. One electron, helium actually 2 but 1 gone. Lithium actually 3 but 2 gone. Beryllium atomic number is 4 but 3 gone. So all they are having 1 electron. And one simple example you can do. In all these cases there are 10 electrons. N minus 3, 7 plus 3, O minus 2, 8 plus 2, F, 9 plus 1, neon, sodium plus 11 minus 1, magnesium plus 2, 12 minus 2, Al plus 3, 13 minus 3. So now all they are having 10 electrons each. See one more. Yes, sulfur minus 2. So 16 is sulfur, 2 gained, 18 electrons. Chlorine minus chloride, 17 plus 1, 18 electrons. Argon, 18. You can take here potassium plus 19 actually, 1 gone, 18. Calcium plus 2, 20 actually, but 2 gone, so 18. So all these can be called as isoelectronic. So this is part 1. We'll take like small videos, atomic structure. These are important basic terms of atomic structure. We'll meet again. I will upload all this one by one. So this is part 1 of atomic structure. We'll complete all the atomic structure around in 10 parts. Have a wonderful time. Good day. Signing off. This is Laxma.